Problem number 7. Find an equation of the line that contains a given point and is perpendicular to the given line. And then use a graphing calculator to verify your results. So we have a given line here, and what we need to do, by the way, an equation of the line that we want would look something like this, where we would want to look for the slope and the y-intercept. Now, perpendicular. If we want it to be perpendicular to this, that means the slopes are what we would call negative reciprocal. That means if we can somehow find the slope of this line, we'll call it m old, the slope of the new line is going to be a negative reciprocal of m old. Alright, but finding the slope of this line isn't so obvious. So what we need to do is to find the slope of anything you want to solve for y, write it in slope-intercept form. Get y by itself and look at the number next to the x. So let's rewrite this equation. 3x minus 5y equals 9. And let's solve for y. So let's bring the 3x over to the other side. And I'm deciding to put the 3x first. It doesn't matter if you have 9 minus 3x or negative 3x plus 9. But I wanted to put the negative 3x first because I want it to look like the slope-intercept form. Now I have to divide by negative 5. Now, just as a caution over here, when you divide by negative 5 on the right side, there are two different terms that you're adding. When you're adding or subtracting, those are terms. There are two terms here, so the negative 5 has to be distributed to both terms. So negative 5, sorry, let's call that a negative 3x over negative 5 plus 9 over negative 5. Well, let's simplify that to negative, and negative is a positive, so let's simplify this to negative 3/5, positive 3/5, sorry, positive 3/5 x minus 9/5. Okay, so what's important to get out of this is the slope, and we have the slope. Now we know that the slope is supposed to be, of the new line, is supposed to be a negative reciprocal. So with all this business over here, is slope of the new line is going to be equal to negative 1 over the slope of the old line, which is 3/5. So when you have a denominator, a fraction in the denominator, let's move that up to the numerator. And when we move it up to the numerator, we get 5/3 over 1. So this is your new slope. Alright, so that's half of it. Now let us take that slope that we got, put it into this equation, and then use our point to solve for b. So y is equal to negative 5/3 x plus b. We're going to borrow the point 2 comma negative 5. We'll put 2 in for x and negative 5 in for y. And we're going to solve for b. So nothing cancels. I have negative 5 is equal to negative 10/3 plus b. I want to add negative 10/3 to both sides. So off to the side here, let me just find common denominators, so I have minus 5 plus 10 thirds. Common denominator looks like it's 3, so I would multiply this thing by 3 over 3. That gives me a negative 15 thirds plus 10 thirds, and that's going to give me a b value. This is all for b, right? So all for b, b is equal to negative 5 over 3. All right. So we have our slope, we have our y-intercept. It's a coincidence that they're equal. They're not always going to be equal. So y is equal to the slope, negative 5 thirds x, plus the y-intercept, so that's a negative 5 thirds. Okay. Let's use a graphing calculator to verify the results. And what I want to do is I want to graph two things. I want to graph, well, I'm obviously going to want to graph the new graph, but I want to graph the old one too. Now, the old one is, the original form looks like this, which is not going to be helpful for us. Because when you use a graphing calculator, you need to look at this as a function where y is by itself. Fortunately, we did that work already, so we are going to consider this graph, or this, the form, that's the same line, but this is just written a little bit differently. So let's take our graphing calculators out and graph both of them. So let me clear out what's there. Let me hit y equals. I have a couple of graphs that I don't need, so I'm going to clear those out first. For y1, I'm going to put the original graph. So y is equal to 3/5. Now, the fractions are a little bit funny here, so what I'm going to do is, just to be safe, I'm going to use parentheses. 3 divided by 5, close parentheses, times x, minus, and then I have another fraction, so I'm going to put that in parentheses as well, just to be safe. So 9 divided by 5. Okay, that's one graph. My second one is a negative, and then I have another fraction, so I'll put parentheses, 5 divided by 3 times x, minus, and then another fraction, 5 divided by 3. Okay, those are my two graphs. And again, I want to, I'm not sure how this is going to look like, so let me start by going to zoom and zoom standard. And then if I need to zoom out, I'm going to press 6. If I need to zoom in and out, then I will. Okay, they kind of look perpendicular. It's hard to tell, but because of the way the calculator is set up, the calculator's screen is a little bit wider than it is tall. So we can make adjustments for that. I believe if we go to zoom and z square, that would be 5 to make it look like a square. Then we can see that it actually would look like it's perpendicular. Now again, if we trace, the second function is the y2 function, and that's the new graph that we found. If we trace to try to figure out, if 2 comma negative 5 is in our, and is in that line, I'm going to hit trace y2, and I'm going to type in the number 2, and I hope the y value comes out to be negative 5. And here it goes, negative 5. Alright, so now we found another line perpendicular to a previous line passing through a specific point.